Hello, dear students. How are you all? Hope all of you are well. Actually, I was having some request from many of the students. They were just informing me about the sir. Please teach from J.D. Lee, Concise Inorganic Chemistry. Actually, I am having the Concise Inorganic Chemistry fourth edition written by J.D. Lee. He was a senior lecturer in inorganic chemistry, Loughborough University of Technology. So let's start today's chapter, specially belonging to chemical bonding. And this chapter will be having a good concepts of chemical bonding because as he has given in his textbook, it was a great thing that he had explained in his textbook. So let's start chemical bonding. So as you all are seeing, it is a second chapter, introducing to bonding, how there will be introduction of bonding as he had given in his textbook, attainment of a stable configuration. He just informed that why the elements want to attain the stable configuration. How do atoms combine to form the molecules, and why do atoms form bonds? A molecule will only be formed if it is more stable and has a lower energy than the individual atoms. So this thought as he had given, that was a great thought, that why there is an attainment of a stable configuration. What are the things that makes the atom to a molecule? Why molecules are formed? When they are formed, when they are more stable, when they are getting a lower energy, why they are more stable? These are all the questions. Today we are going to get an answer of these questions. So you can see the question that how do atoms combine to form the molecules, and why do atoms form bonds? A molecule will only be formed if it is more stable and has a lower energy than the individual atoms. कहने का मतलब कि जब भी कोई मॉलिक्यूल का फॉर्मेशन होगा या कोई बॉन्ड का फॉर्मेशन होगा तभी जाके पॉसिबल है जब कोई भी दो इंडिविजुअल एटम्स, व्हेन आई टॉक अबाउट द इंडिविजुअल एटम्स, जस्ट सपोज दैट हाइड्रोजन एंड हाइड्रोजन, व्हेन H2 bond is formed. Have you ever thought that why H2 molecule is formed? Because when this both the hydrogen will has a lower energy than each other, means individual hydrogen atom, if I talk about, when these both the hydrogen atoms will have lower energy than each other, then only there is a more stability of hydrogen atoms. Got it? So to understand what is happening in the terms of electronic structure, consider the first, the zero group elements. Zero group means 18th group, that is the noble gases like helium, neon, argon, krypton, xenon and radon, which are noteworthy for their chemical inertness. You know very well that why these elements do not react, because these elements are having a stable configuration. Atoms of the noble gases do not normally react with any other atoms, and their molecules are monoatomic. You know very well these elements do not combine with another elements, so that's why they are existing in the single atom, that's called a monoatomic, contains only one atom. The lack of reactivity is because the atoms already have a low energy and it cannot be lowered further by forming compounds. Means already it is having a low energy, so they are existing in the nature in the single form of atoms, so it can't be lowered more and more. So that's why you know very well that these elements can't be lowered further into forming a compound. So the low energy of the noble gases is associated with their having a complete outer shell of electrons. This is often called a noble gas structure, and it is exceptionally stable arrangement of electrons. Normally only electrons in the outermost shell of an atoms are involved in the forming bonds, and by forming bonds each atoms acquire a stable electronic configuration. What I mean to say is that if they are having a stable inert gas configuration, why do these atoms will do reactions? Generally this is the case of noble gas. So in this noble gas configuration what happens means these both the elements, means helium, neon, argon, krypton, xenon, radon, these elements, all the inert gas elements are already having a stable configuration. They are having a lower energy, it can't go more lower to form a compound, so that's why they do not do reactions. But except these elements, whatever the other elements are, that their affinity is to gain the stability. When these elements are having less than 8 electrons in their outermost orbit, so these elements try to gain the stability by attaining the nearest inert gas configurations. Okay, so first of all you must understand about the inert gas configurations, and after that we will discuss about the types of bonds. So as I was talking about that most of the stable electronic arrangement is a noble gas structure, and many more molecules have this arrangement. However, the less arrangement than this are commonly attained by the transition elements. Remember, dear students, whenever I talk about any of the elements, that time you must be very careful about these elements. Why I'm telling you? Because this elements has a nature to gain electronic configuration, except the rearrangement. Means if I talk about the S block and P block elements, generally these elements are having a nature to attain the nearest inert gas configuration. But in the case of transition elements, if I talk about the transition elements, D block elements, what will happen? Transition elements can't attain the nearest inert gas configuration, that is effective atomic number, that we'll learn in the standard 12, or you may have learned about the standard 12, this inert gas configuration, right? So if I talk about these all the things, that how do elements get stability, generally you have to remember about the atom stability is only and only because of the nearest inert gas configuration. By donating, by gaining, by sharing, they do this type of reactivities to get a bond, and then they form a chemical bond. So let's start with the discussion of types of chemical bond. Atoms may attain a stable electronic configuration in three different ways: by losing of electrons, by gaining of electrons, or by sharing of electrons. Elements may be divided into electropositive elements, electronegative elements. Now question is what? That how do chemical bonds form? How you will understand that these elements are forming a chemical bond? So generally let's understand about the elements nature, that what are the nature of the elements. You know very well, the elements can be electropositive, the elements can be electronegative. Only two types of elements can be either electropositive or electronegative. Generally we say about the metals are electropositive and the non-metals are electronegativity, right? So electropositive elements means what? The atoms which give one or more than one electrons readily, very rapidly, if they donate the one electrons or more than one electrons. Second thing, electropositive elements whose atoms gives up one or more electrons fairly readily, they are called electropositive elements. That are generally are metals. Metals readily give their one electrons because they want to attain the nearest inert gas configuration. If I talk about the electronegative elements, then electronegative elements generally p block elements. See, electropositive, if I talk about, then that is only the only S block elements, means alkali and alkaline earth metals. But if I talk about the p block elements, means p block means non-metals, especially if I talk about carbon, and after the carbon means 14, 15, 16, 17th group. If I talk about, so they are electronegative elements which has a tendency to accept the electrons. Now question is, elements which have a little tendency to lose or little tendency to gain the electrons. Now according to that only the bond is being formed. Three different types of bond may be formed depending on the electropositive or electronegative character of the atoms involved. Means if you would just want to understand about the concept that why the chemical bonds are formed, what are the reasons of chemical bonds, then you can just say that it is depending upon the nature, that why the electropositive and why the electronegative elements are being formed. So according to that only the bonds can be formed, except that the bond can't be formed. So let's start the three types of that chemical bond. What are the three types of chemical bond? You can see here the electropositive elements and electronegative elements, they give you the ionic bond formation. If I talk about the electronegative elements and electronegative elements, they give you the formation of covalent bond. Electronegative, electronegative, covalent, electropositive, electronegative, ionic, and electropositive element and electropositive element, they give you the formation of metallic bond. Remember that how these bonds are formed and which type of elements are being involved. There are generally two types of elements, that are electropositive elements and electronegative elements. If I talk about the electropositive elements, then you must remember electropositive elements, as I have told you, that S block elements here we consider as electropositive elements. Generally all the metals have a tendency to lose the electrons rapidly, but then also if I talk about the S block elements, they are highly electropositive elements. And if I talk about the halogen family, they are highly electronegative elements. So electropositive and electronegative elements gives the formation of ionic bond. Electronegative and electronegative elements give a formation of covalent bond, and electropositive and positive give a formation of metal. These are the main three types of bond by which you can divide according to the electropositive and electronegative elements. Okay. So now let's discuss about the ionic bonding involves the complete transfer of one or more electrons. So ionic bond involves the complete transfer of one or more electrons from one atom to another. Means, first of all, you must understand how the ionic bond is formed. Ionic bond is formed only and only by the transferring of electrons. Transferring of electrons means from one electropositive to one electronegative elements. When these electrons transfer from one electropositive elements to another electronegative elements, then there is a formation of ionic bond. And covalent bonding involves the sharing of a pair of electrons between the two atoms, and the metallic bonding, the valencies of electrons are free to move throughout the whole crystal. Now you may have seen that how the ionic bond, how the covalent bond, and how the metallic bond is formed. As I have already informed you about the ionic bonding, how these ionic bondings are being involved, how the covalent bonds are being involved. As ionic bonds are being involved by the transferring of electrons from one atom to another atoms, and covalent bonds are involved by sharing a pair of electrons between the two atoms, and the metallic bondings, the valencies of these electrons are free to move throughout the whole crystals. If I talk about any metallic, if I talk about Mn2O10, magnesium pentoxide, you know very well here magnesium, both the manganese and manganese elements having a metallic bond, right? So here they are free to move throughout the whole crystals. Now these types of bonds are idealized or extreme representations, and the one type generally predominates in the most substances. The bond type is somewhere between these extreme forms. As for example, if I talk about the lithium chloride is considered to be an ionic compound, but it is soluble in alcohol, which suggests that it also possesses a small amount of covalent character. In If I talk about, if then the three extreme bond are placed in the corners of a triangle, then compounds with bonds predominantly of one type will be represented as a points near the corners, and compounds with bonds intermediate between the two types will occur along an edge of the triangle, whilst the compounds with the bond showing some characteristics of all the three types are shown as the point inside the triangle. First of all, listen, each and every compound has some different character, you know very well. If I talk about the men's and women in general, if I talk about the boys and girls, you know, boys also have some characteristics of girls, and some girls also have a characteristics of boy. I'm not talking about the gender, I'm talking about the characteristic. As for example, you may have seen that girls like fighting, means they're because of their hormonal strength. They also have some boys characteristic, and some boys also have some girls characters. They like to cook, they like to do the home schedules, or hold the homeworks, whatever the ladies are doing. Generally they like to watch the, means whatever the ladies works are there, they like to do. There are some of the boys also are very polite, just like ladies. So if I talk about, some of the boys are also having some girls characteristics, because you know very well, either if I talk about any gender, either a boy or a girl, both are having the genes of parents, that parents are mom and dad, means lady and gents, both are having some characteristics. Similarly, if I talk about any compound, if I talk about the lithium chloride, as it is given in your example, that lithium chloride, here the lithium chloride, if you just ask to anyone, then it is an ionic compound, but when you dissolve this lithium chloride into the alcohol, it is already soluble in alcohol, you know very well. When you find out the characteristics of this lithium chloride, then you will get some of the characteristics of lithium chloride as ionic and some little bit as a covalent. So generally, if I talk about, each and every compound has some characteristics of metallic, like if I talk about the ionic or covalent. So generally the most of the ionic compound have some of the characteristics as a covalent. Okay, so now let's see, there is a triangles of this metallic, covalent and ionic compound. How you'll understand about this concept, that how these compounds are having some ionic character, or these compounds are having some covalent character. So I'm showing you a triangle. In this triangle you will just see that metallic, covalent and ionic character, and after then you will understand that how these concepts are there. Are you able to see this metallic, covalent and ionic triangle? According to this triangle, what do you see? Here you can see at the top of the metallic, all the metals you are seeing here: lithium, silver, steel, arsenic, tellurium, sulfur. Here you are, just see this triangle very carefully, because after seeing this triangle you will be able to understand the concept of this triangle. This triangle is illustrating the transitions between the ionic, covalent and metallic bonding. Means they are just showing you that by which bond here how you will be understanding the concept of ionic, covalent and metallic bond. If they are forming an ionic bond between the metal and non-metal, then what are the characteristics of, generally you'll understand that how this covalent character increases or decreases, how the ionic character increases or decreases, or how the metallic character increases or decreases. If I had talked about that lithium chloride, right? So you can see here lithium in the metallic form it is coming here. Sodium bismuth, you can see sodium antimony, sodium arsenic, sodium phosphide, sodium nitrite, sodium oxide, cesium fluoride. So as you will see how this ionic bond formations, and after then you can see the covalent characteristics, after then you can see the metallic character in this triangle. This triangle will clear your concepts about the metallic, ionic and anion. Means metallic, ionic and covalent character, how you will understand the concept according to this triangle. This triangle will clear your all the doubt that how ionic compounds are having both the characters of metallic or covalent, or metallic or ionic, or covalent or ionic. Got it? So let's go ahead. Now as you can see on the topic is transitions between the main types of bonding. What is the meaning of this topic, transitions between the main types of bonding? Few bonds are purely ionic, covalent or metallic, but most are intermediate between the three main types and show some properties of at least two and sometimes all the three types. Generally, as I have told you, that each and every compounds have some little, I'm not talking about the whole 100%, but I'm talking about the percentage ionic character. In the covalent bond, if I talk about, then there will be a little percentage of ionic character. So you have to calculate the percentage ionic character. So as I have already informed you about that, the transitions between the three main types of bonding, as you have seen, the few bonds are having some purely ionic characteristics, but generally if I talk about the intermediate, about the three main types of these atoms, then you can see the ionic bonds are formed when the electropositive elements react with electronegative elements. Electropositive elements react with electronegative elements. Just consider the ionic compound sodium chloride. A sodium atom has the electronic configuration of 1s2, 2s2, 2p6 and 3s1, and the first and second cell of the electrons are full, but the third cell contains only one electron. When these atom reacts, it will do so in such a way that it attains a stable electronic configuration. The noble gases have a stable electronic configuration, and the nearest noble gas to sodium is neon. So neon means sodium would like to gain the neon electronic configuration, that is 1s2, 2s2, 2p6. If the sodium atom can lose one electron from its outermost cell, it will gain the nearest inert gas configuration of neon. As already I have told you, if the sodium atom can lose one electron from its outermost cell, it will attain this configuration, and in doing so the sodium acquires the net charge of +1 and is called a sodium ion, that's a sodium plus. The positive charge arises because the nucleus contains electron protons, which each with a positive charge, but there are now only 10 electrons. Sodium atoms tend to lose an electron in this way when they are supplied with the energy, and so the sodium is an electropositive element. When sodium donates or sodium loses one electron, and it forms a positive charge on its sodium ion plus electron. Chlorine atoms have the electronic configuration of 1s2, 2s2, 2p6, 3s2, 3p5. They are only one electron short of the stable noble gas configuration of argon. So what it will do, it will attain one electrons, and they will gain 1s2, 2s2, 2p6, 3s2, 3p6 configuration, that is of argon. When chlorine atoms react, they gain an electron. Thus the chlorine is an electronegative element. Cl plus is equal to Cl minus. The gaining of an electron and electrically neutral chloride atom becomes a chloride ion with a net charge of -1. When the sodium and chlorine reacts together, the outer electron of the sodium atoms is transferred to the chlorine atom to produce sodium ion, that is sodium plus and chloride minus ion. So here which type of force is that? That is electrostatic attraction between the positive and negative ions hold the ions together in a crystal lattice. The process is electrically favorable as both sorts of atom attain the stable noble gas configuration, and the sodium chloride, sodium plus and chloride minus is formed readily. This may be illustrated diagrammatically in the Lewis diagram showing the outer electrons. You can see here the sodium is having one extra electrons and chlorine is having one lack of electrons to attain their nearest inert gas configuration. As you can see here, the sodium plus and chloride minus ion. right? Sodium plus and chloride minus ion. So according to that, you will understand how these concepts are, right? So sodium chloride compound is formed as an ionic compound. Sodium loses one electron, chlorine gains one electron, and electrostatic force of attraction hold this both the cation and anion and give you a compound of sodium chloride. So as you can see here, the formation the formation of calcium chloride, if I talk about CaCl2, it may be considered in a small way. Calcium atom has two electrons in their outermost shell, and calcium is an electropositive element. So each calcium atom loses two electrons to two chlorine atoms, forming a calcium ion Ca2 plus, and the two chlorine atoms gain Cl minus, showing the outer electronic this way. This may be represented as the following. You can see here that calcium is having two outermost electron and chlorine is having a lack of one electron. So both the chlorine will get one electrons from the calcium, and calcium will gain Ca2 plus charge, and both the chlorine atoms will gain Cl minus charge, and in this way the calcium chloride gives the ionic bond formation. I hope if you have liked this ionic bond formations of GDLA books, then definitely comment and like and share this channel. If you will give a good comment, then definitely I'll make the covalent and metallic bonds also. It depends upon your the like, share and comments, that if you have enjoyed this video, if you have liked this video, if you have understand the concepts of the GDLA, then definitely I'll make in the next video about the covalent bonds, metallic bonds. That's all for today. Thank you very much. I hope all of you have enjoyed. Don't forget to like and share this channel. Thank you very much.